Next is electrostatics of conductors and later. Conductors and insulators were described briefly in chapter 1. Chapter 1 the described Toramde. These are the ideas you have already have in class 10. Class 10 and knowing and they kang of idea me amduni adu issue high game high betang. Conductors I targadi they are going to conduct something. Kainongkakti mana conductor ni chenhalani. Akoigi chapter Z electrostatics havani charges kamari mayam lainari ni aduna sirigi mapasida mana conductor hai targadi conduct tawdorisi charges ne. Insulators hai targana charges mayam zi sathandab sathandab adoi targadi mois insulator na hairni. Conductor ki example aibu iron bar ambu khalengalo where manungda electrons mayam channelini current channelini mo mayam se conductor oidoini. And then insulators ai targi they dry wood kumba mo mayam se the charge sen mungamaroi therefore insulator oidoini. Then if the wood becomes wet so targadi mo yam ngamaktoini adu kanda de kai hairni mo se conductor chungaktoini. Conductors contain mobile charge carriers. Mobile adi link bayaba charge carrier mayam we have any they are electrons. So in metallic conductors these charge carriers are electrons. In a metal the outer valence electron part away from their atom and are free to move. Metal dadi kai haire mana outer valence electron metal kakniko outer valence electron hai targadi kaino magi outermost shell da leiba electron mayam dene valence electron hai si chemistry de yam bajana dum tawmani sigma electron mayam je kai they are free to move. These electrons are free within the metal but not free to leave the metal. Metal du khaktani man chat pe yari si atei diya de. The free electrons form a kind of gas. They collide with each other and with the ions and move randomly in different directions. Conductor manung the electron valence electron mayam do tungaina doini moi chak ning chening mai kai the random moina mayam kuja set toina. In an external electric field they drift against the direction of the field. Electric field am external field am som na kanjida tharen khalo do target the electric field direction from the they drift against the direction of the field. Do target the moin salam do som na kanjida against the sumdring na parallel oina fazana keno nine salam mani sumaina the positive ion matter of the nuclei and bound electron remain held in their fixed positions. Nuclear mayam di bound electron mayam di ke dore na hai leng dana layin electron huziki valence mayam duni leng je adu nataba leng da mayam duna we call it bound electron. Bound na de far ga thambaduni maming sina dum ta adabani. In electrolytic conductors the charge carriers are both positive and negative ions. Noigi kaino daga cell gi sembada hotbada chemistry they are many thazai electrolyte kanaga tawda the tholakadaba carrier me anduni positive ions negative ions and a layer easy. But the situation in this case is more involved. The movement of the charge carriers is affected both by external electric field as also by the so-called chemical forces. Chemical force me amnazu effect our kani electrolytic p kaino sidadi movements dadi conductor matam daibani. We shall restrict our discussion to metallic solid conductors. When a conductor gi khana matam da moi bujik my electrolytic conductor gi khana ro only for metallic solid conductor khana ni si khana matam sida ya maru oiba magi properties mayam ni important results na haire sidadi yeng na si. Ahambada first point inside a conductor angi manungda electrostatic field is 0. Magi electrostatic field is 0 nin hai. electrostatic field hai taragadi field oidoini electric field oidoini kanana puthorpa leng the charge na puthorpa oidoini electrostatic hai. Consider a conductor neutral or charged conductor make the there are also many there may also be an external electrostatic field. External electrostatic field in the static situation when there is no current inside or on the surface of the conductor. Current manung dasu surface dasu leitraba matam dabini. Current is when charges move. The static situation there will be no current. The electric field is zero. Electric field zero. Everywhere inside the conductor. Conductor ki manung du niko charge electric field conductor ki manung zero. This fact can be taken as a defining property of a conductor. A defining property of a conductor right there. Conductor is kaino conductor has some substance some material ni kamain muigi manung zida electric fields in a zero when current later kanda in surface ni kangde manungda later kanda and mine has we have any defining property is a conductor has free electrons. Conductor is free electrons. As long as electric field is not zero, the free charge carriers would experience force and drift. In a static situation, the free charges have so distributed themselves that the electric field is zero everywhere inside. When the free charges may distribute electric field zero inside manung conductor is the electric field zero distribute. The electrostatic field is zero inside a conductor and high resistance. This is an important point. Next, at the surface of a charged conductor, the electrostatic field must be normal to the surface at every point. Charged conductor oirava charged conductor is surface electrostatic fields electrostatic field charge electrostatic fields normal to the surface at every point electrostatic fields in a surface normal if E vector electric field vector were not normal to the surface it would have some non-zero component along the surface. Mana non-zero some surface later surface direction perpendicular or in electric fields in a 90 degree is the laka doing manana moyani ki marakte live angle must be 0 degree nata targadi theta is 0 nata targadi it will have some component non-zero component lekanin haire adu targadi ki dore free charges on the surface of the conductor would then experience force and move na zero targadi they will experience some force can experience Taurani adu leng bahorani leng targadi it will no longer be electrostatic field or in the static situation E should have no tangential component on the tangential component thus electrostatic field at the surface of the charged conductor must be normal to the surface at every point aduna electrostatics in anywhere any point electrostatic fields in a surface parallel then number 3 the interior of a conductor can have no excess charge in the static situation interior of a conductor is the excess charge levi adi habni excess of the hen habni idea to makhadan hen khangani yangu. A neutral conductor has equal amounts of positive and negative charges in every small volume or surface element. Neutral oitargadi koina small volume element buni khangde surface element buni khangde khanaba matam sida equal amount of positive and equal amount of negative charges yaw habni sigi small volume sida dunabu neutral oina leidoini. When the conductor is charged, conductor is in a charge or matamdadi the excess charge ahin charge miyamdu can reside only on the surface of the in the static situation dadi kamain tawre charge on leng targadi mana leidoi si leibai yari si magi surface to the khaktane adai dagi lakpano si se Gauss law da yengsi kamai la ino habdo. Consider any arbitrary volume element V inside a conductor. Conductor am laideng khalo inside a conductor is the my small volume element V am conductor khanare. On the closed surface as bounding this volume V element, the electrostatic field is 0. So V is a small element S am going to bound away ye adoi targadi E dot ds kanaga thain dogini flux puthoke kanaga tog targadi or electric field kamain tawne da koi mamang logic ta haigre that inside a conductor manung the electrostatic field is 0 nena aduna kedore magi si volume small volume element inside of that conductor is magi electric field is 0 electrostatic field is 0 tarni. Thus the total electric flux through S is 0. E dot ds to flux puthok pe abni si bu kai tare 0 tarni q by epsilon naught pu hiring khalo 0 tarni because the electric field is 0. Electric field is 0 taramni na kai hayare charge is 0 and high biarni manungda charge like is in high biarni do targadi natra. Hence by Gauss law there is no net charge enclosed by S enclosed over charge like but the surface S can be made as small as you like. The volume V can be made vanishingly small. This means that there is no net charge at any point inside a conductor. Inside a conductor there might charge until I static condition that then excess charge must reside at the surfaces on the surface में हम लोग लेके दबने plus point खलो मथक surface ले जिधर लोग लेके दबने मनुंग ले भी आ रहा है next thing is electrostatic potential is constant throughout the volume of the conductor and has the same value as inside on a surface. Electrostatic potential is the constant throughout the volume of the conductor or in higher. This follows from results 1 and 2 above. Since electric field is 0, electrostatic field is 0 inside the conductor and has no tangential component. Tangential component is surface like absorb component. Chamta laita bani maze electrostatic field ziga ziga normal the linear dabni surface ziga tangent or laita later no work is done in moving a small test charge within the conductor and on its surface that work done the tawdre test charge moving ke kakemta later static when later that is there is no potential difference between any 2 points inside or on the surface of the conductor. Manung the su surface the su potential difference amta later and hibne potential the laiduini electrostatic potential is the laiduini adubu potential difference the laite haiba potential difference lerem targadi difference bu lerem targadi ayam badagi yam da barom saning ba tendency lerem duini adun charge me am the lem ba duini there is no such thing here hence the result magi potential is a constant in a line high doing If the conductor is charged, conductor is in the charge, so electric field normal to the surface exists. This means the potential will be different for the surface and a point just outside the surface. So higher point number 5 the electric field at the surface of a charged conductor is E equals sigma by epsilon naught and cap bana. See no yang si makha harmony. See sigma is that it is surface charge density near that it is charged by some area area se koi ni se da khalak matam da matsa delta s na khalai yamna pick pe area element s ne na dunu sumaina tamni si main ta okay ni example where sigma is the surface had a charge density and n cap is a unit vector normal to the surface in the outward direction. This is my outward direction, then cap is money. To derive the result, choose a pillbox. So this is the layering of pillbox size. A short cylinder as the Gaussian surface about any point P on the surface. The pillbox is partly inside and partly outside the surface of the conductor. Surface of the conductor ki karamna manung na sange haire, karamna mapanda leiren haire. It has a small area of cross section delta s and negligible height. Magi height is negligible nen haire yamna pm tare. Then magi cross sectional area is na kai neva delta s nena haire areas. Just inside the surface, the electrostatic field is 0. Just outside the field is normal to the surface with magnitude E. Magi direction E vector. Thus, the contribution to the total flux through the pillbox comes only from outside. Outside outside cross section of the pillbox. Manung electrostatic field 0 This equals E ds delta s d pagi positive force sigma is 0 de entire charge positive or negative or since over the small area element delta s, electric field E vector may be considered constant and E vector and delta S are parallel or anti-parallel. The charge enclosed by the pillbox is that charge is equal to delta sigma delta S analyzing charge is by Gauss law flux phi z E dot ds and phi is also q by epsilon naught, where q is the charge enclosed by the Gaussian surface. See is a E ds is the later madam the when cos theta and theta do 0 like doing E ga see delta S mark the labor. So this is the latent color. The theta do 0 is parallel or anti-parallel or minus holocanico. Adugi minus to consider taudre hosiki in the magnitude not the laure dunani stage the absolute analyze. Magi positive oiba can wear sigma 0 de helaga negative oiba 0 di targa ganagal either anti-parallel oiba parallel oiba adugi idea the E dot ds must be later, then q, this is q divided by epsilon naught na 6 the later. So the gidi do we are so the gi a delta s and the yawi mamzi som the gizu kakatana by the arroy lautok, then pidoreta horizon equals sigma by epsilon naught na. Minus tark pane do targadi sida layerꯁꯤ derive ꯇꯧꯔꯦ ꯀꯩꯅꯣ ꯑꯣꯏꯅ ꯏꯒꯦ ꯍꯥꯏꯇꯥꯔꯒꯅ ꯀꯃꯥꯏꯅ ꯇꯧꯔꯦ e vector ꯍꯥꯏꯇꯥꯔꯒꯅ n cap ꯑꯅ ꯍꯥꯞꯄꯤꯔꯝꯃꯒ ꯂꯣꯏꯔꯦ